We have another example. Please notice that this time, okay, we have series circuit, okay? R1 is connected in series with R2. We're supposed to determine the unknown quantities, okay? So other words, we're supposed to find voltage across resistor R2 and current, which is going to be simply current total. Okay, so we have to find voltage across resistor R2, VR2, and we're supposed to also find I total. Please notice again that we have series circuit. It means that I total is going to be equal to I R1, and this is going to be also equal to I R2. Okay, so this is going to be simply my KCL, Kirchhoff current law for this circuit. Okay, now, so in order to do so, we're supposed to find the total resistance. R total is equal, this is series circuit, we simply add the resistances, so I have R1 plus R2. So what I have 200 ohms plus 20 kilo ohms. Okay, so our total is equal 20.2 kilo ohms. Okay, so this is my total resistance. Okay, this is my R total. If you want to see how we're supposed to enter this into the calculator, simply enter 200 plus 20 exponent 3. This is equal 20.2 kilo ohms. Okay, so now we're supposed to find I total. I total is equal voltage 1 over R total, where voltage 1 is equal 16 volts. 16 volts divided by 20.2 kilo ohms is equal 16 divided by 20.2 exponent 3 is equal 792.07 microamps. Okay, so this is my total current. Okay, so we have to find right now the voltage across resistor R2. Okay, because we found already I total, and let me remind you one more time that I total is also equal to the current which goes through resistor R1, and this is also equal to the current which goes through resistor R2, because this is the series circuit. Okay, in series circuit all currents are the same. Next we're supposed to find the voltage across resistor R2. Okay, in order to practice voltage divider formula, I'm going to find this voltage by using voltage divider formula. Okay, so let me remind you that voltage divider rule or formula is looking like this. So Vx is equal voltage source times Rx over R total. Okay, so I'm going to simply write that this is equal 16 volts times Rx, which is equal 20 kilo ohms, over R1, which is R total, which is basically the sum of these two resistances. So I have 200 ohms plus 20 kilo ohms. Okay, so this is equal. I'm going to use the calculator, and I have to simply write 16 times open parenthesis 20 exponent 3 divided by open parenthesis 200 plus 200 exponent 3, close parenthesis. This is equal 15.84 volts. Okay, so this is the voltage across resistor R2. Okay, I forgot to write the formula for voltage across resistor R2, but simply just realize that this X has to be substituted by 2, and this X supposed to be also substituted by 2. So my formula for V2 is supposed to look like V2 is equal voltage source times R2 over R total, and this is basically what I have over here. Okay, so this is my voltage across resistor R2. Okay, VR2. In order to make this problem a little bit more interesting, I'm going to find the voltage across resistor R1 as well. To find voltage across resistor R1, we can simply use KVL, okay, KVL, which simply says that voltage source, in this case is V1, is equal VR1 plus VR2. Okay, this is KVL for the series circuit. So in order to find VR1, I simply write that VR1 is equal voltage source, which is V1 minus VR2. V1 is equal 16 volts minus VR2, and VR2 is equal 15.84 volts, and this is equal, okay, so let's practice the calculator. Okay, so I have 16 minus 15.84. Okay, this is a very simple calculation. This is 160, okay, 160 millivolts. Okay, we have times 10 to negative 3. This is millivolts. This is 160 millivolts. So 160 millivolts. Okay, so this is voltage across resistor R1. Okay, and next we can find also total power. Okay, P total is equal voltage source times I total. Okay, so V1 is equal 16 volts times I total, which is equal 792.07 microamps. Okay, so this is my formula for total power. So I have 16 times 792.07 exponent 6 negative. This is equal 12.67 milliwatts. 12.67 milliwatts. Okay, this is my total power. Of course, we can find power P1. P1 is equal I total times V1, where I total is equal 792.07 microamps, times V1. We found VR1. Okay, let's call it, sorry, this is VR1, this is not V1, VR1. V1 is my voltage source, so this is my VR1, and I have I total 792.07 microamps times VR1, and we found VR1 is equal 160 millivolts. So this is equal, I'm going to use the calculator again, so I have 792.07 exponent 6 negative times 160 exponent 3 negative. This is equal 126.73 microwatts. So I have 126.73 microwatts. Okay, so this is the power at resistor R1. Now I can find P2. P2 is equal I total times voltage across resistor R2. So I have 792.07 microamps times VR2, and VR2 we found is equal 15.84 volts, so this is 15.84 volts, and this is equal, again I'm going to use the calculator, so I have 792.07 exponent 6 negative times 15.84. Okay, so this is equal 12.54 milliwatts. 12.54 milliwatts. In order to find P total is equal P1 plus P2, where P1 is equal 126.73 microwatts plus 12.54 milliwatts, and this is equal, okay, I have 126.73 exponent 6 negative plus 12.54 exponent 3 negative. This is equal 12.67 milliwatts. 12.67 milliwatts. Please notice that these two answers are correct, so it means that everything, whatever we did so far, is correct. So we can say that we finished with part A. Now we're supposed to go to part B. Determine the reading of the amp meter if 20 kilo ohm resistor is shorted. Okay, if resistor 20 kilo ohms R2 is shorted, so this is like a piece of wire over here. Okay, this is just the conductor over here. So resistance is theoretically 0. So total resistance of my circuit is going to be simply just 200 ohms, because if this is just piece of wire, because resistor is shorted, okay, so the total resistance in this circuit is equal to 200 ohms. So we have to determine the reading of the amp meter if 20 kilo ohm resistance is shorted. So I have, this is my part B. So my I total is equal V1 over R total. V1 is equal 16 volts over R total 200 ohms. Again 200 ohms because R2 is shorted. Okay, it behaves like just piece of wire. So I have 16 divided by 200. This is equal 80 milliamps. So I have 80 milliamps. Someone is going to ask, so if this resistor is shorted, how many volts I'm going to measure across this resistor? You're supposed to realize that voltage is equal current times resistance. Okay, so in this case I have to find VR2. So I have to multiply total current, because this is series circuit, times resistance R2. I total we found is equal 80 milliamps. And we have to multiply by R2, but we said R2 is shorted, so the resistance is approximately 0 ohms. So 80 milliamps times 0 ohms gives me 0 volts. So voltage across resistor R2 in this situation is going to be equal 0 volts. Someone wants to find the power, so P total is going to be equal power at resistor R1, because we have just one resistor in this circuit, because R2 is shorted. So this is simply I total times voltage source. Okay, so we can say that this is P total is equal I total 80 milliamps times the voltage source 16 volts. This is equal 80 exponent 3 negative times 16 is equal 1.28 watts. Okay, watts. So this is my total power and power P1. P2 is equal 0, because if there is voltage across the resistor 0 and resistance is equal 0, so we can say that power is equal 0, because power is equal current times voltage. If the voltage across the resistor R2 is equal 0, so automatically power across resistor R2 is equal 0. So, part C. Okay, in part C, the problem is asking me to find the reading of the voltmeter if R2 is open. Okay, if R2 is open. So if R2 is open, so this is like a gap. Okay, so your voltmeter is going to measure nothing else, just simply voltage source. Because if this resistor is open, your voltmeter is going to see the gap over here. And gap in electronics means extremely large resistance. And you're supposed to keep in mind that the highest voltage is going to always concentrate across the highest resistance. So if this resistor is open, so there is extremely high resistance, so entire voltage, the maximum voltage I suppose to say, is going to appear between these two terminals. So it means across the voltmeter. So this is going to be the highest voltage. And keep in mind that KVL says that voltage source is equal V1 plus V2. So if entire voltage concentrates across resistor R2, so voltage across resistor is equal R1, and voltage across resistor R2 is equal 16 volts, because this is open circuit. So part C, VR2 equals 16 volts. Okay, and the current, if someone is going to ask for current, I total, because this circuit is open, right? So this is open circuit. I total theoretically is 0. Okay, theoretically, because of course some current will flow by the voltmeter. Okay, there is like internal impedance of the voltmeter, but at this moment this is we can say irrelevant. That's why we are going to say that current is equal 0. At this level we can say that current is equal 0, because the internal impedance of the voltmeter is not specified. Internal resistance, I'm supposed to say, of the voltmeter is not specified. That's why I'm going to say that I total is approximately equal 0 amps. Okay, and these are basically the solutions to my problem.